The European Southern Observatory captures a cosmic spiral. SpaceX and NASA failed to launch. Weather violation at the Cape causes a delay. And no is the answer. The questions may surprise you. Dr. Brad Tucker doing some myth busting. It's Saturday, May 30, 2020. This is Talkin Science Uncut, produced live right here on Trekzone. I'm Matt Miller. Thanks so much for your company. Let's dive into it.
Across Apple Podcasts, Spotify, Google Podcasts and YouTube, this is Talking Science with Dr. Brad Tucker and Matt Miller.
Indeed, he is with me. It is Dr. Brad Tucker. Happy Tuesday to you, Dr. Brad.
Yeah, it's a big Tuesday.
It is a big Tuesday. It's a big week for science and space news here at Talkin Science. We've got so much to get into, but first of all, everyone can find you on social media, on Facebook, Dr. Brad Tucker, on Twitter, btucker22, and of course, Trekzone, all over social media as well. Brad, let's dive into the headlines. No, not a moment to waste.
Talking Science Headlines.
And the headlines for us this week start with Hayabusa 2. It's just passed 2,000 mission days.
Hard to imagine that it was launched 5 years ago or so, but after a year and a half trip to the asteroid and then hanging around the asteroid in the year playing on the asteroid and then a trip back, it's a long day for a spacecraft.
It is a very long day. Another one, a bright flash in the night sky over the weekend here in Australia. A lot of discussion on this one. Was it a meteorite? Was it an alien? Was it space junk? What was it, Brad?
Look, it looked strange, but it was definitely space junk. It was the third stage of a Russian Soyuz rocket, which had launched, in the evening Australia time. And I think it was a combination of, it was Friday evening at 6 p.m. Everyone was at home because of lockdown. It was clear skies. And so it was really quite the show. It's a very good thing, but it was all planned, always planned to land off the coast of Tasmania.
And our last headline, the largest antenna in the southern hemisphere is getting a makeover. Deep Space 43 at Tidbinbilla.
Yeah, it's a bit delayed for coronavirus reasons and lockdown, but they've been planning this upgrade for a long time to allow them to do the next wave of deep space communications and the new round of spacecraft. So it's going to be offline for a while, which means communication with Voyager will be a bit restricted because it's one of the few antennas that can talk to that distant craft in the edge of our solar system.
Hayabusa 2 on its way back to Earth, surpassing 2,000 mission days, which is absolutely incredible. That meteorite over the eastern seaboard skies of Australia, turns out it was space junk. Those that didn't believe me on Twitter, well, you've heard it from an astrophysicist now. Surely you've got to believe that. And Canberra's beautiful Deep Space 43 radio telescope there at the Tidbinbilla tracking station, getting a makeover, getting that started, which is absolutely fantastic. Glenn Nagel from the Tidbinbilla tracking station, a three-time guest of the show, I think he is. If not, he will be a three-time guest. He's coming up when we return to the main show on Monday. This Monday, Larry Nemenchek is back. Then Glenn will be here to chat about that makeover, exactly what is going on. I remember in 2016 when we visited him down there in Canberra, he was talking about so much activity in the solar system that the radio dishes that they've got just can't keep up. There's not enough bandwidth time. So this upgrade certainly is helping. And we'll have all those details on that chat with Glenn on our Monday show, which is returning this Monday. Glenn will be here the following Monday, which is very, very cool. I think that's the 8th of June. So look out for that one. And to look out for that one with ease, you should find Trekzone across social media. Do that thing. Facebook's got the wrap-up. Twitter's got the latest. Instagram has got Trek episodes, Orville episodes, and coming very, very soon, Babylon 5 episodes as well. Tumblr's got the posts, which I've got to remember to keep posting there. YouTube has the visually enhanced editions of the podcast, which you're obviously watching here now live. So subscribe to us here, ring the bell to get notified, leave a comment with what you think of what we're doing, the topics that we're covering, and that would be absolutely fantastic. We're going to engage with me. Please, I'm here all alone in a coronavirus lockdown. And of course, podcasting. That was my attempt at a joke. I'm sorry. Don't forget the podcasting in your favorite podcasting app. Get us on the go, on your go, when you're on the go. Because sometimes you just don't have time to sit down and watch a YouTube video. Alrighty, I'm going to try and string my words together for the next segment that I present to you live. Right now, though, here's my chat with Brad about this newborn planet.
Talking Science, Stories of the Week.
Now, I love this one, Brad. You sent it through. This beautiful orange cosmic swirl. Turns out it's the birth of a baby planet.
This is an actual image. This isn't an animation. This isn't a computer simulation. This is an image of a swirling ball of gas coming together to form a baby planet. And I think that's the remarkable thing here is that, we know planets form. We've long calculated and thought how the gas swirls around to form the planet. It's amazing to see that, that process happening in the here and now in the truest sense.
Absolutely incredible to think.
It almost looks like a galaxy, right? But what you're seeing is really this, planet being formed. And that's kind of the cool thing when we talk about how stars and planets and galaxies form. There's actually, a similar mechanism and process involved in it. And so it's nice to be able to see that.
It's a funny thing with scale, isn't it? Like you say, it could be a galaxy, but given that we're so zoomed in on it, it's just a planet. To think that this is what goes into it.
That's right. And this is what would have happened, with Earth, Mars, all these other planets we like to talk about. It would have all happened in this very similar way, in this unique way, really. And being able to just see that with your own eyes not only is amazing, but again, it's one of these principles of science. We do the calculations, we do the predictions, and it's nice to go out and carry that out and prove it.
To our understanding, this is how planets form. The gas combines and little bits of specks and material and stuff like that forms. And then to make a rocky planet, the rocks start coming a little later on. It's not just not all the time necessarily rocks clumping together.
No, that's right. It's a layered approach almost. And it's kind of, again, what you're almost seeing in this image, the way it's swirling is you get the gas spinning through it, and then you get some of the heavier stuff laying around it. But if you don't have that heavier rock around it, you just swirl and keep swirling more gas, and you end up as one of the gas giants. So again, it tells us a lot. It shows us a lot. And the fact that modern technology, from this to the Event Horizon Telescope of the first black hole to lots of the other things we've covered, is amazing to see. Things that we thought happen, we predict happen, we calculate happen, but we weren't ever sure we were really going to see like this.
Now, these observations were made by a research team made up of astronomers from France, Taiwan, the US, Belgium, and it was all carried out with the European Southern Observatory's Very Large Telescope in northern Chile. Very much an international collaboration.
Yeah, and it's using one of the great instruments that it has, and the policy of open skies and open research allows people to point telescopes and new ways of viewing the sky at different things, and this is what pops out.
So, Brad, what's next with this research? Is it changing what we knew? Is it turning everything on its head, or is it sort of confirming stuff for us?
No, it's a good question, because it's one of these things where it's a fundamental kind of confirmation of what we thought was happening, and those are good things. Those are principles that we need to do, even though we calculate it, we measure it. It's good to almost prove it within a reasonable doubt. And so sometimes the confirmation of exactly what you knew confirms, well, we knew it and we were calculating it all right or wrong. So that's always a positive tick in the box.
Very, very cool that we can get that close to a brand new planet, adding to the collection in our universe, all that gas swirling together to coalesce and form a new planetary body. Very, very exciting. Well, look, the next segment that I was going to bring to you on today's Talkin' Science Uncut, produced live here across Trekzone's social media, was going to be Brad and I talking about the SpaceX launch with the segment that we recorded on Tuesday for Thursday's live show. Unfortunately, due to the weather, that launch didn't happen, and it's now going to happen tomorrow. We're going live for that second attempt, and Brad and I have recorded a new chat, which you'll get to experience tomorrow. I don't want to spoil that surprise, so instead I'm going to run my chat with Dr. Andy Thomas from the World Science Fair in 2016. Now, in that interview, I have been calling Andy Australia's first astronaut. Now, while that technically is correct because he's the first Australian to be a member of the astronaut corps, he wasn't actually the first Australian to fly in space. That honour goes to oceanographer Paul Scully Power, who flew on STS-41, which is very, very cool. And it'd be great to reach out to Paul and have a chat with him as well. But for now, here's my chat with Dr. Andy Thomas from the World Science Fair in Brisbane in 2016.
Talking Science, Stories of the Week.
Today's guest is so far Australia's only astronaut. His name is Dr. Andy Thomas, and he's joining me from the World Science Fair, happening for the first time outside of New York in Brisbane. Dr. Thomas, thanks for your time. What inspired you to be an astronaut?
Well, when I was growing up, it was the early days of the space program. I remember, I'm old enough to remember the flights of Alan Shepard and John Glenn. And of course, I remember the moon landings very clearly. I was a student at university. And I looked at those and thought, what a great adventure. Wouldn't it be amazing to be involved in that? But for a kid growing up in Adelaide, that wasn't a very realistic prospect. But later in life, after I'd got an engineering degree and a PhD, I realized I could actually make that dream come true. And I then focused my career to getting the kind of credentials that I thought would be needed to become an astronaut, and I was successful in applying.
Well, you managed to achieve that with a Bachelor of Engineering in Mechanical Engineering with first-class honours from the University of Adelaide. And then you moved to the US and worked with Lockheed Martin throughout the 80s. In 92, you were selected by NASA and spent 12 months training to join the astronaut corps. What did that involve?
Yeah, I should say I also got a PhD at the University of Adelaide, and I think that was actually a pivotal education step that I needed in order to apply to the astronaut program. My first flight was, as you said, in 1996, and that was a 10-day mission on the shuttle Endeavour. And that was preceded by a year of pretty intensive training on the specific systems that we were going to fly on that mission, as well as on all the systems that make the shuttle operate, because we had to operate the vehicle safely. And that's the kind of thing you typically do when you're training for a specific flight.
Before you flew in space, you worked as an astronaut support person. What does that role involve?
Oh, that was actually an assignment I had. While you were waiting for a flight or between flight assignments, NASA give you a job to support the overall flight program. And the first one I had after I finished my astronaut candidacy training was what they call an astronaut support person, which is the role you have to go down to the Cape and act as a liaison between what the people are doing to process the launch vehicles at the Cape and the astronaut office, which is back in Houston. So I spent a lot of time going back and forth to Cape Canaveral and working with the launch directors. And then ultimately I had the role on one flight, STS-59, I remember it, to actually assist the crew strapping in on day of launch and closing the hatch on them and sending them on their way.
That must have been a surreal experience to strap in those astronauts and send them off to space.
It was. And one of the things you get to do is you go out to the launch pad about 5 hours before the actual launch. And of course, there's no one there because of the dangers, and it's very quiet, and you have the whole shuttle to yourself. You're just sitting in the shuttle by yourself, listening to the communication loops, and it's usually the middle of the night, and that was a very surreal moment, and it made me realize just what an exciting adventure I was involved in.
Well, you served as mission specialist on flights STS-77, 102 and 114, logging more space flight hours than any other Australian. How does it feel to be Australia's pioneer of space?
A little humbled. I have to admit that I'm guilty of the sin of pride that I did become the first Australian citizen to fly in space. I've had, as you remarked, 4 flights, and that's 4 more than I ever expected to get, and they've been amazing flights, and I look back on it with great fondness, but also, to this day, a certain element of disbelief that I actually got to do that.
One of those missions involved 141 days aboard Mir. What's it like living on a space station?
You know, the flight on Mir was perhaps the most important in my career, and it was one of the highlights, if not the highlight of my spaceflight career, because I preceded that by spending a year in Russia training to become a cosmonaut. And when I was growing up in Adelaide, I might have dreamed of being an astronaut, but I never in my wildest dreams thought I could become a cosmonaut. But I got to do that, had to learn Russian, and then I went on board the Mir space station with 2 cosmonauts who didn't speak English and spent 20 weeks there. And it was an extraordinary experience. It was one of the great experiences of my life, being weightless for 20 weeks and enjoying orbiting the Earth 16 times a day for 20 weeks.
What are the differences between a cosmonaut and an astronaut?
There's really not many. The only distinction is that a cosmonaut learns to operate a Russian spacecraft, an astronaut learns to operate a NASA spacecraft.
Having spent time on Mir and flying 2 missions to build the International Space Station, how does it make you feel to watch fellow astronauts like Commander Scott Kelly spend a full year in space?
I respect him for that. A year would be a tough flight, but I could have done it. Time flows very quickly when you're in space. It becomes a very tranquil experience, actually, when you're up there. I watch the people that are flying today, and I have to admit to a certain amount of envy that they're getting to fly. Even though I've had some great flight experiences, sometimes I feel a pang of jealousy that they're flying, and it'd be nice to fly again, but I have no complaints.
Are there any plans for you to return to flight?
Not for me, no. I retired from the agency 2 years ago, and I've hung up the flight suit and I'm leaving it for a younger generation.
Well, speaking of that younger generation, what do you think is next for human space exploration?
I think what we're going to see is we'll continue to fly the space station for about another 10 years, and we'll use that to test out the basic systems we need to go beyond low Earth orbit. I think then you'll see a return to lunar space, not necessarily to the lunar surface, but to lunar orbit perhaps, where we'll deploy a deep space habitat that will let us evaluate how those habitats operate and what is required to support them for long periods of time in space. And that'll give us the basic engineering we need in order to fly missions to Mars, because sending humans to Mars is the holy grail of human space exploration, to which all the agencies really aspire.
Well, short of our own space agency, how does an Australian become an astronaut?
Right now, there is not a career path for an Australian to fly in space because Australia does not have a relationship with NASA to fly astronauts. I think that's something that could change in time, and I would encourage all the young people here to promote that idea with their political leaders so that one day Australia could become part of the international spacefaring community.
Fantastic, Dr. Thomas. Thank you so much for your time.
My pleasure. Thank you.
4-time shuttle mission veteran Dr. Andy Thomas from the World Science Fair in 2016, chatting with me about his experiences on the shuttle and also on board Mir for 140 plus days, which is absolutely fantastic. The original intention there was for our Talkin Science Uncut was to bring you Dr. Brad Tucker and my chat about the SpaceX launch, which didn't go ahead in the end on Thursday due to a weather violation. It's now going to happen tomorrow, and we're going to go live again. Dr. Tucker has some more insights on that launch. We'll have the launch live as well, of course, and that's going to be very, very exciting. Well, you're going to have to get across to Trekzone's socials to know when that's happening. Facebook, Twitter, Instagram, and YouTube, and Tumblr when I get around to posting the posts there. It's something that I should do a little bit more often. Also, don't forget the Trekzone is working on a new paint job, and it would be really great if you could support that endeavour. PayPal.me/Spiromedia if you've got any money to give. We can get it done sooner rather than later. But right now is our last story of the week, which is myth-busting. Dr. Brad Tucker's had enough of some of these stories that are circulating online that aren't factual, and he's going to bust those myths right now. The answer is no. Dr. Brad Tucker has the questions.
Talking Science, Stories of the Week.
Alrighty, Brad, and our last story this week. You're going to tell me no a couple of times. We've got some myths to bust. The sun is in its quietest period, and that's it. All hell's going to break loose. An ice age is coming.
Yeah, unfortunately, no. This is an easy no. It's one of those things. Yes, the sun is in a quiet period. The sun has an 11-year solar cycle. And people said, well, maybe this is associated with mini ice ages or will change the temperature of the planet. It doesn't really work like that. The heat output and the energy output of the sun doesn't change. It's just the magnetic activity and the solar flares. So it's actually a good thing. There's less solar flares. That means there's less types of radiation bombarding it. There's less flares and the chance of radiation harming astronauts in space. So good for a rocket launch. It's a classic example of, we know the sun affects life here on Earth, obviously, but the timescales are just not the same. And what we see relative to environmental changes cannot be explained by sun burps, unfortunately, or the lack of sun burps.
Well, the sun does experience regular 11-year intervals. So there's solar maximum and solar minimum. So this is the solar minimum period that we're in now. This is scientific fact here that these things happen, and we haven't been having ice ages every 11 years.
That's right. Every 11 years, it's not all of a sudden, really cold. And even when people say mini ice age and imagine ice age, it's not like woolly mammoths walking around with snow covered. We're talking about a couple degrees temperature dip, in average temperatures. But even then, it doesn't happen every 11 years. We would see that. And conversely, every other 11 years, every top of the cycle, it doesn't get hotter, right? People, because we've been monitoring the sun for 200 plus years. In fact, why Mount Stromlo, where I work, was built was to help this global project to monitor the sun. As we've talked about before, we have good baselines of how the sun varies over these 11-year cycles. And, every 11-year cycle is slightly different than the other, just as seasons are. But we don't see those correlations with the temperatures here on Earth. Having said that, scientists at NASA are saying that we're in a grand solar minimum. That's right. It's one of those where the minimum is weaker than others. That seasonal fluctuation is worse than others. But it means it's just the sun is really boring to look at. That's actually what it means. Is if you have a solar telescope looking for solar flares and sunspots, there ain't nothing going on in the sun. All right. Well, the other question that I have for you, Brad, NASA scientists claim to have discovered a parallel universe where time moves backwards. This is a comical one, because not only is it a no, but no one really knows how the whole story started. I mean, yes, we do. But so firstly, the experiment was a telescope in Antarctica looking for neutrinos, these high energy particles. And what they found was particles kind of going the wrong direction. We expect them to coming from space, so coming from the top down. These appear to be coming from the bottom up, which doesn't really make sense. It's either that they've made it all the way through the Earth, or they bounced off the ice or something. And so obviously it's an interesting result. Neutrinos are one of the more least understood particles in the particle family. And so obviously it requires some explanation. It could be how neutrinos move. There could be elements of new physics here that we don't know neutrinos. Now, obviously, one of the always out there ideas, and it's a legitimate one, is this could be a sign of higher level physics, what we call CPT violations, and something that could be a sign that there is the anti-universe, not necessarily parallel universe, right? The opposite pairs. And so that obviously led to anti-time, which obviously led to time running backwards, which obviously led to parallel universe, which led to the New York Post saying there's a parallel universe existing before us. Oh no. Look, I know it explains 2020, but I don't think that's necessarily the answer.
I love my mum's. When my mum read this article, she said, "But where is it?"
Exactly. Well, so and this is actually a kind of a cool thing when we talk about antimatter. Antimatter being a real thing that we know and physically can measure. We know we don't have enough antimatter in the universe, because if we had equal amounts of matter and antimatter, that equals zero. And we're here asking that question. So we know that it's not zero.
Or are we?
And so where the antimatter goes, how it evolves, it's a big area in physics. And so how does it sit alongside us is always one of these interesting questions about it. But unfortunately, I don't think it's going to be, we have evidence of it. Look, hey, there is an outside chance in 100 years, more experiments prove that it could be true. But in Antarctica, this was done on a big balloon with an instrument, but there's also what's called ice cube, which is this big array of neutrinos buried deep underneath the ice of Antarctica, and it didn't detect it. So clearly, there's something we just don't understand, which will probably be way more boring than parallel universe.
Proving that you can't believe everything you read online. Dr. Brad Tucker busting some myths there, which is absolutely fantastic. I reckon we might do that one a bit more often as well, because there is so much misinformation. I don't want to use the F and N words. Misinformation out there. People believing things that other people are posting without actually checking them. So Talkin' Science will become your destination for fact-checking. Alrighty, well, it's time to wrap up this edition of Talkin' Science Uncut, produced live across Trekzone's social medias. Don't forget, if you can, support me with that new paint job, paypal.me/Spiral Media. All those funds will go into the kitty to pay a local business here in Australia to design the website and implement it, which would be absolutely fantastic. Trekzone on all the social medias. Facebook's got the wrap-up. Twitter's got the latest. Tumblr's got the posts. Instagram's got Trek and Orville episodes, plus Babylon 5 coming soon. And, of course, YouTube with the visually enhanced editions of our podcasts, which are available on your favourite podcasting app. Dr. Brad Tucker's on Facebook as well, Dr. Brad Tucker, and Twitter, btucker22. Engage with him for some science facts as well. We're going to be back live again tomorrow with attempt number 2 to launch America, SpaceX and NASA gearing up to launch astronauts Doug and Bob on the Crew Dragon capsule, on the Falcon 9 rocket. It's going to take them about 19 hours to get up to the space station, but it's about 19 hours until that launch window opens. We're going to be live with that one, so join me again, won't you? 6 a.m. tomorrow for another edition of Talkin' Science Live. I'm Matt Miller. That's all we've got for you for this uncut edition. Thanks so much for watching.